Armored cable is permitted to be used with non-metallic boxes if an internal bonding means is provided in each box. This internal bonding means ensures electrical continuity between all metallic raceways, enclosures, and other non-current carrying conductive materials connected to the armored cable system. An internal bonding means is required because non-metallic boxes do not inherently provide a path for fault current to return to the source. In the event of a ground fault, such as a live wire coming into contact with a metallic component of the electrical system, the fault current needs a low impedance path back to the source to trip a circuit breaker or fuse, effectively disconnecting the circuit and preventing electrical shock or fire hazards. The internal bonding means essentially creates this path within the non-metallic box, allowing the fault current to flow safely back to the source. There are several acceptable methods for providing an internal bonding means in a non-metallic box when using armored cable. One common method is the use of a metal strap. This strap is typically made of copper or another conductive metal and is designed to be securely connected to the armored cable's bonding conductor, which is the bare or green insulated wire within the armored cable assembly. The metal strap is then connected to a grounding screw or terminal within the non-metallic box, which in turn is connected to the grounding conductor of the circuit. This arrangement ensures that any fault current flowing through the armored cable's bonding conductor will have a direct and low impedance path to ground. Another acceptable method is the use of an internal metal liner. This liner is essentially a metallic sleeve or enclosure that fits inside the non-metallic box. The armored cable's bonding conductor is securely connected to this metal liner, which then acts as a continuous grounding path within the box. The metal liner must be properly bonded to the grounding conductor of the circuit to ensure effective grounding. This method provides a more robust and reliable grounding connection compared to a simple metal strap, as it offers a larger surface area for contact and reduces the risk of loose connections. Beyond metal straps and internal metal liners, any other approved method that ensures electrical continuity can be used as an internal bonding means. The key requirement is that the method must provide a reliable and low impedance path for fault current to flow back to the source. The specific method used will depend on the design of the non-metallic box and the requirements of the electrical code. It is crucial to understand that simply connecting the armored cable's bonding conductor to the non-metallic box is not sufficient to meet the requirements of the electrical code. Non-metallic boxes are not designed to conduct electricity, and they cannot provide a reliable grounding path on their own. The internal bonding means is specifically designed to bridge this gap and ensure that the armored cable system is properly grounded, even when connected to a non-metallic box. The National Electrical Code, or NEC, provides specific guidelines and requirements for grounding and bonding electrical systems. Section 250 covers grounding and bonding in detail, including requirements for equipment grounding conductors, bonding of metallic and non-metallic enclosures, and grounding electrode systems. It is essential for electricians and electrical contractors to be familiar with these requirements to ensure that electrical installations are safe and compliant with the code. When installing armored cable with non-metallic boxes, it is important to carefully inspect the non-metallic box to determine if it is specifically designed for use with armored cable and if it includes a built-in internal bonding means. Some non-metallic boxes are specifically designed for use with non-metallic sheath cable or NM cable and may not have the necessary provisions for connecting the armored cable's bonding conductor. In such cases, it is necessary to use a separate metal strap or internal metal liner to provide the required internal bonding means. When connecting the armored cable to the non-metallic box, it is important to ensure that the armored cable connector is properly tightened and that the bonding conductor is securely connected to the metal strap or internal metal liner. Loose connections can increase the impedance of the grounding path, which can reduce the effectiveness of the grounding system and increase the risk of electrical shock or fire hazards. In addition to providing an internal bonding means within the non-metallic box, it is also important to ensure that the armored cable itself is properly installed and supported. Armored cable must be supported at intervals not exceeding 4.5 feet and within 12 inches of every box, cabinet, or fitting. This support helps to prevent the cable from being damaged or strained, which could compromise the integrity of the grounding system. It is also important to protect the armored cable from physical damage. Armored cable is designed to provide a degree of protection against physical damage, but it is not indestructible. The cable should be routed in a manner that minimizes the risk of damage from impact, abrasion, or other hazards. In the areas where the cable is exposed to physical damage, it should be protected by conduit or other suitable means. Finally, it is important to remember that electrical work can be dangerous, and it should only be performed by qualified and experienced electricians. Working with electricity can be life-threatening if proper safety precautions are not taken. Always disconnect the power to the circuit before working on any electrical components, and always use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician to do the job for you. Proper grounding and bonding are essential for electrical safety. By understanding the requirements for using armored cable with non-metallic boxes and by following the guidelines of the National Electrical Code, you can help to ensure that electrical installations are safe and compliant with the code. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical work. The internal bonding means is a crucial safety feature, and its proper implementation is essential for protecting people and property from electrical hazards. Neglecting to provide an adequate internal bonding means can have serious consequences, including electrical shock, fire, and equipment damage. Therefore, it is imperative to take the time to understand the requirements and to ensure that all electrical installations are properly grounded and bonded. The metal strap, internal metal liner, or other approved method provides a reliable path for fault current, minimizing the risk of electrical hazards. Careful attention to detail during the installation is key to ensuring the effectiveness of the internal bonding means. This includes ensuring that all connections are tight and secure, and that the grounding conductors are properly sized and installed. By following these guidelines, you can help to create a safe and reliable electrical system.